So I will be talking about problem number 4 on exam 2. So you're told that there are 6 wires that are connected to a battery right here, and that the circuit is allowed to reach steady state. So the battery has an EMF of E, and the wires of the circuit are all made of the same material and they all have the same length. The only thing is that this one has it's a little more thick and it has a cross-sectional area that is 4 times larger than the rest of them, than the rest of the wires. So the first part of the question asks you to write down 3 valid loop equations for this diagram right here. So if you think about the loop rule, it basically tells you that when you travel around an entire circuit loop, you're going to return to the starting voltage. And mathematically, it is that the sum of the loop and the voltage in it is equal to 0. And it could be a physical loop, but it doesn't always have to be. If you think about it, an easier way to understand it is to use the sign of delta V as seen by an observer walking along the loop in the direction of the arrow. So, sorry, it would be this way, not the way that my pen was going. And this only holds for steady state circuits, which is something to remember. So you also know that V equals to the integral of V equals to the integral of E dl. And in terms of the circuit, it would just be V equals to EL. So E times the length. And so moving on to go ahead and find the loop rule, or to find the loop equations for this. So you can start with the upper loop. So you start with the EMF. So you know EMF minus E1L1 minus E3L, E1L, since they're all the same length, they would all be L. So EMF minus E1L minus E3L minus E1L equals to 0. So that would be the first one. So you know that, EMF minus E1L minus E3L minus E1L equals to 0. And then you can simplify that to EMF minus 2E1L minus E3L equals to 0. And then the second one, you can look at a smaller loop down here. So that would be E3L minus E2L minus E2L minus E2L equals to 0. So this loop right here. So that one would be, I'll write it right here, E3L right here minus E2L minus E2L minus E2L equals to 0. And you could simplify that as well into E3L minus 3E2L equals to 0. So that's another equation right here. Here, I'm going to box them so it's easy to tell. And then there's one more you can do if you look at the big loop. And it's usually easy to forget, but make sure you also look at the big picture. So for that, you know that you can start up here. So EMF minus E1L minus E2L minus E2L minus E2L minus E1L equals to 0. So writing that down, we can just go ahead and simplify it in our head, but it will be EMF minus 2E1L minus 3E2L equals to 0. So that is the third loop equation. So once you have all 3 of these, it asks you to find the node equations for these relating E1, E2, and E3. So what we know about the node rule, so it's in steady state and the currents are constant and no charge accumulates in or on the wires or at the junctions. And there could be a tiny bit of charge on the wire, but in steady state, that charge is not always increasing or decreasing. And the charges on the capacitors are also constant. And so the Kirchhoff's node rule is the current in equals to the current out. So in terms of this problem, you know that at the left node, you know that I1 equals to I3 plus I2. And you also know that I equals to sigma A1 E1, relating to the capacitance. And then so simplifying this equation even more, you have A1 E1 equals to A3 E3 plus A2 E2. And then you can cancel it out because it's the same on each side. And then, so you know that A1 E1 equals to A3 E3 plus A2 E2. And then what's given is that the cross-sectional area for this thickness for E3 is 4 times the one of all the other wires. So you know that the area of 1 is equal to the area of 2, and then the area of 3 is equal to the 4 times the area, or sorry, the area of 1 is 4 times the area of 3, or area of 3 is 4 times the area of 1. And so plugging that into the equation, you can simplify it even more to A1E1 equals to 4A1E3 plus A1E2. And then you can go ahead and cancel out the A1 since that is the same and it could be factored out. And then you know that E1 equals to 4E3 plus E2. And then the third part of the question asks you to solve your systems of equations using the node rule and the loop rule to find the values of E1, E3, and E2. So you can go ahead and do that by setting the equations basically equal to each other. So you know that E3L minus 3E2L equals to 0 from up here. Well, where did that go? From right here. And so if you set that equal to each other, then you have E3 equals to 3E2 when it's simplified. Bring it to the other side. And then you also know from your loop rule equations that E1 equals to 4E3 plus E2. Sorry, you know that from your node rule equation, not your loop rule equation. And so you just plug in what you know right here. So you have E1 equals to, 4 times 3E2 plus E2, and that simplifies to 12E2 plus E2, simplifying to 13E2. So you know that E1 equals to 13E2. And then you can use your loop rule equation. So you have that EMF minus 2E1L minus 3E2L equals 0. And simplify that with what you know. So EMF minus 2, 13E2L minus 3E2L equals 0. And then bring all that to the other side, and then you'll have EMF equals to 29E2L, and then you know that E2 equals to EMF over 29L when you divide both sides by that. And then you can use that value and plug in the rest. So then you can also find the value of E3 in that same manner, which ends up equaling to 3 EMF over 29L, because you know that E3 is equal to 3 times E2. So you just multiply E2's value by 3. And then for the last part, you would use a different loop rule equation. You know that EMF minus 2E1L minus 3E3L equals to 0, which is the one from right here. And you plug in the values that you know to find that. And you'll end up with EMF minus 2E1L minus 3EMF over 29L times L equals to 0. Cancel the L's out. And it'll simplify to E1 equals to 13 EMF over 29L. Oops. There we go. And that is how you do problem number 4.